One example of a neutralization reaction would be when you have something like this and this. If you look them up on table K and table L, you'll find that this is an acid and this is a base. And when you put them together, you would get a salt and a water. So one of the things you want to look at is the part of the acid that falls off is that front part, the H's. The part of the base that comes off is the OH's. And when you put that together, that's the water. But it would make no sense to say H2OH2. You would never say that. So just remember, you know water is H2O, or as I told you, I write it HOH all throughout this topic. Okay, I know that makes no sense, 2 H's, 2 OH's, and we only end up with 1 and 1 here. But later on, we can balance it. We know that this is the correct formula for water. So drop off however many H's are on the front and however many of OH's are on the back here, and worry about them later. The other part that comes together is the calcium and the sulfate. Remember that when we put formulas together, the metal must come first in the formula. So Ca is the metal. You would look him up on the periodic table. He's a +2. SO4 is a -2 from table E. So when they come together as CaSO4. That's calcium sulfate. So you do have your acid plus base gives you water plus your salt. Now, why would we actually do this? This is all about why we use the titration formula on table T. Why would I want to take an acid and a base and put it together to get neutral? Well, this example would be for if you had something like antacid or acid indigestion, you might want to counterbalance some of the acid with a base in order to kind of make your stomach relax and feel not so upset. So some of those antacids that we take, like Tums or different types that you've seen in the grocery store, are essentially giving you that balance of the acid in your stomach, which it's not H2SO4 in your stomach, it's HCl, but will balance it out to make your stomach feel less uneasy. So if I were to take this titration formula from table T, MAVA equals MBVB is the formula, and the M is molarity of the acid, volume of the acid equals molarity of base. This will tell me how much of the acid will be balanced out with how much of the base. So if you look here, I wrote what volume of 2.5 molar, that's my concentration of this, which is my base. How much volume of that particular base will I need to neutralize, cancel out 30 milliliters of the 3.2 molar H2SO4? So what I want to just set up is, look, this here is my acid. I know that I have 3.2 as my molarity for my acid, and the volume of my acid is 30 milliliters. The molarity of my base is a given 2.5 molar here, but volume I do not know. So if I solve here for X, what I end up finding out is that I will get 38.4 milliliters. In order to balance out this much acid at that strength, I will need to have 38.4 milliliters of the 2.5 calcium hydroxide.